Mr. Mac here. In this video, I'm going to go over some solutions here for 1.5. In this section, we're factoring. And so let's just jump right on in here. I'd like you guys to answer these verbal questions. I feel like they're just easy to skip, but they're important. And so let's take a look at this. If the terms of a polynomial do not have a greatest common factor, does that mean it is not factorable? Okay, so let's, at first you might think, well, if it doesn't have a common factor like in number 4 down here, that it's not factorable. But what if we have something like x squared plus, let's say, 5x plus 6? Think about this polynomial right here. Is it possible to factor that? Think about what we would do here to factor this thing, and if it's yes or no. So I'm going to go ahead and let you think about that one. Let's look at number 4. Find the greatest common factor. I'll do a couple of even ones here. So what common factor do these 3 terms have? Well, it looks like they're all even coefficients, so that would be 2. Anything bigger than 2? Let's see, 4. No. So a 2 comes out, and then let's see, an x. So it looks like just 2x for this one. And just to say, if I were to factor that, this would be 7 plus 2y minus 9y squared. But it's asking for the greatest common factor, which would be 2x. Let's take a look at 6. Greatest common factor here. Let's see. 30, 45, 135. So a 5 comes out of these terms. Anything that ends in 0 or 5 is factorable by 5. Let's see. Anything more. 5. Well, a 2 doesn't come out of 45 or 135. So 5, 3. Let's see. 15. Does a 15 come out of... So 135 is 5. Let's see, and 5, so that would be 17, right? I think 17. 5, we got a 1. No, sorry. 2, 27. My bad. 2, that would be 10. Trying to do it in my head. 35, 27. Okay, so 27 comes out. So 3 does come out of that. So we got 27, 3, 9, 3, 3. So a 3 comes out of 3 and 5. So let's see, if I take out 15, but a 2 doesn't, so 31. Okay, so I think a 15 comes out of both of these. So let's see, x cubed, x squared, x, so only an x. I got a y squared, and y cubed, and a y. I'll just see what this would be. So this would be 2x squared, that y came out, minus, this is 3, right? So this would be 3xy, plus, let's see, if a 5 and a 3 came out of 135 right here, that'll leave us with 9. 9, and x is gone, y squared. Yeah. Okay. It's that one. And then 8. All right. So 8. Let's see. 3. Oh, it looks like a 6. Does 6 come out? 9 times 6 is 54. 6 times 3 is 18. 6 times 6, yeah, it looks like a 6 comes out. Anything more than that? Let's see. One way we can do this is by making factor trees. Okay, so 2, 2, 3, 3. That was the 36. 18 is 2, 9, 3, 3, and 54 is 2, 27, 3, 9, 3, 3. Okay, so let's say I got a 2. That's common. I got a 3. I got another 3. Okay, so 2, 3, 3. So that's 18 comes out. So 18 will come out. And then j, my biggest j is to the second. And then k to the second. Okay, so that's my answer there. Maybe I'll start boxing these things in. Okay, you guys see how I use the factor tree to help me out? I mean, I could grab a calculator, I guess, but I'm working with the math here, so I have a solid understanding of it. Let's take a look at, so I got some odd ones. The solutions are in the book, but let's work out a few of these. Factor by grouping. Okay, so we've got, this is in standard form, ax squared plus bx plus c. The leading coefficient is something other than 1 here. So that's my a value is 2, my b value is 9, and my c value is negative 18. So what we want to do here is we need to multiply a times c together. It's our first step. And that would be 2 times negative 18, which is negative 36. Now, we need to find the factors of negative 36 that are going to add to the b term, which is 9. Okay, so these have to add up to whatever the b term is. And so that's not very good. Let's try that again. Let's make a little table here. Okay, factors of negative 36 that add to 9. So we got negative 1 and positive 36. That's 35. That didn't work. Negative 2 and 18. That gives me 16. That didn't work. Let's see. Negative 3 and 12. That adds up to 9. That does work. We do like that. Negative 4 and 9 is 5. And that didn't work. So I think we see right here. Negative 3 and 12 are the two factors of negative 36 that add to 9. So now we're going to write (2a squared), and we're gonna break these two factors up. Now 2 doesn't go into negative 3, but 2 does go into 12, so I'm going to use a 12 first. 12a, and then minus 3a, and then I write my negative 18. Look, all I've done is replace the 9a, which was here. I just broke this up to 12a minus 3. It's still 9a. Now what we're going to do is we're going to take the greatest common factor of the first two and then the second two. So the first two, the GCF is 2a. So 2a. If I factor that out, I'm left with a plus 6. And then over here, the last two, I'm going to take out a negative 3. And that leaves me with a plus 6. We really want to make sure that this binomial quantity for both of these is the same. It got to be the same. So let's factor out an a plus b. I have two terms here. They both have a common factor of a plus b. If I take an a plus, 6, b, it's a 6. I wrote that. A plus 6. If I take an a plus 6 out of this term, I'm left with 2a. If I factor a plus 6 out of this term, I'm left with negative 3. And that is my factored binomial. Come on now. Okay. Let's try 17. Okay. Factor the polynomial. All right, we have same situation. We have our leading coefficient is something other than 1. So we're going to follow the same steps here. We're going to do a times c, and then we're going to find the factors that add to b. So a times c is 10 times negative 9, which is negative 90, and they're going to have to add to negative 9. Okay, so factors of negative 90 that add to negative 9. So negative 1 and 90 are factors, but that's 89. Negative 2 and 45, that's 43. So we got to do way more here. So let's see, 4 go into 90. No, 4 doesn't go into 90. 5 go into 90. Let's see. It does, because it ends in 0. So 1, 5, 4, 8. Okay, negative 5 and 18. If I add those together, did I do that right? 5, 1, 95, 1, 40. Yeah, that gives me 13. Okay, so let's try. So that didn't work, right? And I need this to be negative 9. So really what I should be doing is make the more negative number here so I get a negative sign. So now let's try 6. Let's see if 6 goes in. 6 should go in, right? $15. 6 and negative 15. And if I add those, I get negative 9. And that is my pair right there, is 6 and negative 15. Okay, so now I'm going to rewrite the polynomial, but instead of negative 9h, I'm going to write, let's see, it doesn't matter, I'll just do 6. 6h minus 15h minus 9. So I just broke up the middle term here. And then now we're going to take the greatest common factor of the first two and the second two. So 10h squared and 6h, I can take a 2h out. That leaves me with 5h plus 3h. And then here I can take a negative 3 out. And that leaves me with 5. So I took an h out of here. I've got to fix this. It's not an h right here. Okay, let's delete that. If you caught me, my mistake before I did, good for you. Okay, h, and then negative 3 out of negative 9 is a positive 3. Okay, do you see how we get the binomial term ends up being the same here? Just fix this, make that look a little better. Okay, so 3h plus 3, 5h plus 3, 5h plus 3. Let's take the 5h plus 3 out of these two binomial terms, out of these two terms. So a 5h plus 3 out of this first term would be 2h. Out of this second term would be minus 3. And then that's it. That is our factored trinomial right there. All right, that was 17. What am I going to do now? 23. All right, so 23 is something a little bit different. We've got 16x squared. This is a perfect square, and 100 is a perfect square, and we're subtracting. So this is the difference of two perfect squares. That means, like the a squared minus b squared, that means we have, the factors are going to be a conjugate pair, a plus b, a minus b, because the middle terms here would cancel. So this is just going to be 4x, okay, the square root of 16x squared would be 4x, square root of 100 is 10, and so the pair would be 4x minus 10. If we were to FOIL this, we get the first 4x times 4x is 16x squared. Our outer 4x minus 10x would be a negative 40, and the inner would be 10 times 4x would be a positive 40x. Those two terms would cancel, and then 10 times negative 10 is negative 100. So that is the difference of two perfect squares. We get a conjugate pair binomial. And we've seen a couple of those already. 29. Let's take a look at this. 144b squared, that's a perfect square. 25c squared, that's a perfect square. We're subtracting. So this is the same thing. 12b plus 5c, 12b minus 5c. And that one is done. I gotta box this in. Gotta do it. Okay. So we just did two of those. These other ones here, similar. Let's see, what else do we have here? Maybe 30. One of these, I guess. I guess I'll do 31. So this one right here, so 49, so this is a perfect square, this is a perfect square, we're adding. I suspect that this is a perfect square binomial, which means that, let's say I had a plus b, okay, and I squared it. This is just simple perfect square binomial here. And let's see, what example is this one in our packet? It is, okay, so this is number 4, right? And so we would end up getting here a squared. So you see this a squared and then the b squared as our last term. And then we would get an ab plus ab middle term if we FOIL this. So it's going to be a squared plus 2ab plus b squared. This is our perfect square expansion. And so let's see, the 2ab right here is, so if the square root of 49 is 7 and the square root of 144 is 12, 2 times 7 times 12, does that equal 168? All right, so let's see, 2 times 7 is 14, so 14 times 12, let's see, 8, 2, 0, 4, 1, add those, 168. It does. This is a perfect square, guys. So it's just going to be 7n plus 12 squared. Okay? Square root of that, square root of that. We're going to use the plus sign this time because we have a middle term. And that's our solution right there. Hope that makes sense. Okay. We've got some cubes here. Just get back to my notes. Right, so there is an equation that we want to know here. I'm just going to write it right here. I've got a cubed plus b cubed. This is going to expand into this. We got a plus b, we have a binomial, times a trinomial, a squared minus ab plus b squared. Okay, so the way I remember this is just plus minus plus. So we have the same equation, basically expansion with the plus or the addition or the subtraction, the sum or the difference, except the signs change. It's minus plus plus if we have the negative. So if we have a negative 1 over here, this one would be minus plus plus, which means that we would have a cubed minus b cubed would equal a minus b, and then this would be a squared plus ab plus b squared. That's a plus right there, not divide. Okay? So we just need to, 216 right here is a perfect cube. So if we take the cube root of 216, you can do this on a calculator. Try, take 216 and raise it. You can use your caret and you can raise it to the 1/3. You'll see it's 6, right? So 6 times 6 times 6, 6 cubed is equal to 216. Okay, don't take my word for it. Check it yourself. Okay, so we got the x cubed is a perfect cube, so that's going to be x plus 6. And this is going to be, so x squared minus, okay, so my x a is my x term, and my b is going to be 6. So this is going to be minus 6b plus 6 squared. 6 squared is 36. And that's my final answer right there. Okay, might as well do the difference of cubes. Difference of cubes. So my a term in this case, so if I take the cube root of this right here, so what's the cube root of 64, right? It's 4. So 4x is my a term. And then my b term over here, what's the cube root of 125? It's 5. So this is going to be 4x minus 5 times, so I'll just write this out, 4x squared like this, plus this is going to be 4x times 5 plus 5 squared. Okay, so I got 4x minus 5 times 16x squared plus 20x plus 25. That one's done. Okay, that's the difference of two cubes. Perfect cubes, right? And 45 is the last one I want to do. Okay. These are a little tricky. We want to try to find the greatest common factor with these two terms. I have two terms here, separated by a minus sign. That's term 1 and that's term 2. They have the same base here, 2c plus 3, 2c plus 3. They have different exponent, negative 1/4 and the 3/4. So what we're going to do is we're going to factor out the base here, 2c plus 3, with the smallest exponent. So that's going to be this one. This one's smaller. Okay, negative 1/4 is definitely smaller than 3/4. So I'm going to factor out right here. And that's going to leave me with, so I just took this whole thing out of this first term. So it just leaves me with 3c, right? I just factored this whole thing out here. Minus, now I've got a 5. Okay, so I'm taking out a negative 1/4 here. I'm subtracting a negative 1/4. So the base stays the same. Okay, but so you guys remember let's just review really quickly here. So if I have x squared times x to the 3rd, I get x to the 5th, right? It's my product rule right there. I add the exponents. What if I have x to the 3rd and I factor out, let's say I wrote 5 to the 3rd. Let's say I have x to the 3rd and I factor out a negative 2 out of that. So if I factor out a negative 2, that would leave me with x to the 5th. So if I take out a negative 2, x to the negative 2, then this exponent got bigger by 2. Well, I hope that makes sense, because if I multiply it back together, when I use my product rule, I add the exponents, and that would just get me back to x to the 3rd. Do you guys see that? If I factor out an exponent that's negative, it makes the exponent get larger in the term that we factored. So that's what's going to happen here. If I subtract a negative 1/4 out of this, it's the same as adding the 1/4. So this is going to give me 4/4 right here. So I'm doing this. So if I just read it, I got 3/4 minus negative 1/4. That turns to a plus, right? So now I've got 2c plus 3 to the negative 1/4. Got that 3c right here, minus 5, 2c plus 3 to the 1st. Okay, 3/4 plus 1/4 is 1. I don't even need to write that exponent right there. Let me just get rid of it. And then now I can distribute the 5 in here. So I still got 2c plus 3 to the negative 1/4. 3c minus 10c minus 15. 3c minus 10c is negative 7c minus 15. And then over here I've got 2c plus 3 to the negative 1/4 still. And that's it. That's my answer. These are a little challenging, but I think they're kind of interesting. I think they're worth doing, and especially understanding our rules for the exponents. Okay, that's all I'm going to do here. I did a bunch, and hope that makes sense. And please do all the practice set and check your solutions. The odd ones are in the ebook. I'll check you later.